Hello and welcome to Fun with R. In this session I will illustrate some of the fun things you can do with R. Hopefully I can convince you that you can do a lot of cool stuff without too much complicated coding. Now, the goal here is not really that you understand everything that you see. After going through the other material in this course, hopefully everything will fall into place. Right now, the best thing you can do is, of course, enjoy the show, then copy some of the code from the handout, run it yourself, see if you can get it to work, and then see if you can maybe play around with it a little bit, change some things, do slight variations. Probably what's going to happen is that it's going to give all sort of error messages and doesn't work, but that's totally fine. You can't break anything, you cannot do anything wrong, just have fun and see what you can do. Now, we will start by getting us some data from Twitter. Of course, there's all kind of things wrong with Twitter as a data source, but the nice thing is that it's mostly public and it's fairly easy to get. Before we can get down to business, however, you will need to install some packages. Packages are external libraries of functions that you can do. And so when you downloaded R, you got all the statistics, you got all the things built into R. But built into R isn't the way to get tweets, and other things like the visualizations, a lot of things we'll be doing will be using other packages, and these packages need to be installed first. So we will install a number of packages. For example, we'll be using the tidyverse, and we will be using a package called Quantida for the text analysis. We will be using a package called iGraph for network analysis. And we will be using a package called topic models to do topic models, obviously. And finally, we will be using two packages to get the data. One is called rtweets and the other is called tmaptools. Now, these last two you don't really need to use because we've already cached the data for you. You can just get our data, but if you also want to scrape Twitter yourself or do the geocoding, you'll have to install these packages as well. Now, I would advise you just get these commands, run them all, or if you're a little bit more lazy than this, you can also go to packages, install, and then type them here, and it will do exactly the same, and then click the install button. So that while I'm talking here, it can install things on your computer. This might take like between 5 and 30 minutes, so don't worry about it, and it will only have to be done once on your computer. So if you already installed tidyverse, you don't need to install tidyverse again. Now, after installing something, you need to activate it with the library command. So I now activate the rtweet package so I can get myself some tweets. You see that I type the command here and press Ctrl and Enter to run the command, and you see it's run here in the console. Now, the rtweet package is activated, so now I can actually get myself some tweets with a function called search tweets. Why not? Let's search for tweets mentioning Trump. And let's not get too many of them, just 10 of them, and there we go. So in my computer this immediately works because I've already authenticated with Twitter. If you haven't done that yet, what will happen now is it will open a browser, it will ask you to log into Twitter and give R the permissions necessary to search Twitter, so don't worry about that. If you're running this on Colab or in an IPython notebook, things are a little bit more complicated, so in that case, probably skip that for a later time. Now, you'll see that I now have a dataset called tweets, which has 10 observations, the 10 tweets I got, and 90 columns, 90 variables. Let's have a look at what we see here. So every tweet has a user ID, a status ID, the date when it was created, the user that wrote it, so in this case it's Ruby Rockstar 333. And then we have the actual text. So in this case, he is apparently doing a prediction that Trump will win 320 electoral seats versus Biden. The next Twitter user wonders what happens if Trump is unable to govern, and then apparently he goes into a little bit of politics about how Trump was always unable to govern. And you can see here that you get a lot of not so very nice conversations about what Trump is doing, and in this case, of course, it's related to him contracting COVID himself, which happened a couple of days before I recorded this video. So what you see now is with a single command, we've actually scraped 10 tweets. We could also scrape 10,000 tweets if we wanted to. It will just take a little bit longer. And you have these tweets in memory, and you can then do all kind of cool analyses on these tweets. Now, I'm going to cheat a very little bit because we already have downloaded a number of tweets that we'll be using here. That's also easier for you, so you can follow along the example without necessarily having to get the tweets yourself, which we stored at the website for the book that we are writing, called computational social science book.net. And we will be using a other library called Tidyverse, which is a library we're using a lot to actually get the data from the internet. So I guess we don't have to do this as so we again run one command, and this command will instruct the computer to go to this website, download this CSV file, and load it into memory, overriding the tweets dataset. So now we have almost 10,000 tweets and only 8 variables because I removed most of the redundant variables. So now we have about 10,000 tweets, which I sorted by how often they were retweeted. So the most populars are at the top. And we can see here the first one is from Pakistan, which is about secularism and Gandhi and Nehru in India. The second one is about Florida, which is apparently by a girl that just died, which is connected to Florida politics, etc. Right? So here you see 10,000 tweets about Corona that were all gathered around the 25th of September. Now, we have our tweets. What can we do with them? The first thing we might want to do is to just use the structural data, so in this case the date variable, to maybe plot at what time these tweets were plotted. And to do this, we will use a library called LibriDate, which you didn't actually have to install because it's included in the Tidyverse, but we just have to activate this part of it, which has a number of functions for dealing with date variables. So we're going to compute the tweets per hour, and we'll take the tweets and we'll mutate to create a new variable, which we'll call hour, which is the rounded version of the created at column rounded by hour. So if we look at this, what we have now is a new variable, which it just doesn't display because it's too short. Let's try it again. Yep, there we go. And so this is the same date that it's created at, only now it's rounded at the hourly level, so we can start aggregating it, which we'll actually do right now by grouping by the hour and by creating a summary variable, which we'll call n, which will just have the count of tweets. So now we have an aggregate level data set, which only like 24 rows, because there's apparently 24 hours of Twitter in the original data set, which gives us how many tweets there were at every hour of the day. Now we have this beautiful data, we can start plotting it. So we do a ggplot of these tweets per hour. We have to tell it how to connect the data to the what it calls the aesthetic dimension. So the x should be the hour and the y should be the n, and then we add a graphical element, which we do a bar plot with the column elements, and let's run this. And now we see how many tweets we have per hour. So most of the tweets were around 6 o'clock in Europe, and then you see it declining a little bit, especially like between midnight and 6 a.m. There was a lot, and then it goes up a little bit again. Now we can of course make this a lot more beautiful. For example, we could do the classic theme, and classic, sorry, can't type, and then you see that it just changes the background to something that I consider a little bit more beautiful. If you have something called GG themes installed, which is totally optional, but if you do have it, you could also, for example, do the Economist theme. And then you get the typical theming used by the Economist magazine, or you could do the Wall Street Journal. Wall Street Journal, and then you get the color scheme used by the Wall Street Journal. Whatever you like, there's a lot of themes there that you can all explore how they look. So you could do a dark theme, and then you get something like this, right? So this is sort of fun, but it's not quite beautiful yet because this is ugly and this is ugly. So let's add the horizontal label, the vertical label. Wall Street Journal doesn't do labels. And so now we have the horizontal label, the vertical label, and let's add a title here. number of tweets per hour. GG title, contact. There you go. So now in a couple lines of code, we have made a pretty beautiful looking graph, or at least I think it's pretty nice, that shows the number of tweets per hour, and with just a extremely simple change we can use a different theme to create a quite different graph again, all using of course the same aesthetic elements and the same labels, right? Right. So now we have our tweets, and we showed you how you can use the structured data in the Twitter dataset to create a graph. Now let's have a look at the textual data, because of course tweets are all about the text, and we'd like to see what people are tweeting about. The first thing we could do is have a look at the all the words that were used in the tweets. We use something called Quantida for that package. And in Quantida, the main thing you do is you make a document feature matrix or document term matrix. So let's quickly show you what it does. For example, if we have a data set of tweets. Tweets are cool. Then the document feature matrix is basically a matrix where every row is one of the texts, every column is one of the words, and the cell will tell you how often each word is used in each text. Now this is of course pretty trivial if we have two short text, but we can also make this with all our tweets. And then it takes a little bit longer, and then we have a document feature matrix with 10,000 documents, of course, 60,000 unique words. And you can see here the first text mentions the word secularism once, and it also mentions the word off once. The word off is also used in the third text, in the fifth text, etc. Right? So this contains all the frequencies of all the words in all the tweets. And we could use this to make a word cloud. And let's say there will be one at most 100 words. Probably 50 is enough here. Maybe let's do 100. And you see here a word cloud. It's not particularly pretty, but you also see that most of the words here are actually words like of, the, in, punctuation, etc. So what can we do? We can say let's remove the stop words. So we remove English stop words, and let's also remove punctuation. And now it's getting a lot better. We can see there's a strong focus on COVID, of course, on coronavirus, on people. You can see some other words here. Let's see if I can make this slightly bigger. Run it again. Real Donald Trump is over here, pandemic, etc. Now, to make this more informative, let's do two things. First, let's filter our tweets to only use the English language tweets. So we'll take the tweets, we'll filter them so that the language must be English, and we'll pull out the text column, and we'll use that to create our document feature matrix, and do the same thing here, right? So we call this D. So now the stop words are gone, so we don't have the and off anymore, and you can see it's more English. There's no la and some other things that were probably from different languages there. Now, of course, there's all kinds of things we could do here. We could focus on the hashtags. We can focus on everything except for the hashtags. One thing we probably want to do is to get rid of this big hashtag, because that's what we selected the tweets on. So of course that's going to be the biggest one, which we can do by something called DFM trim, if I'm wrong. No, DFM remove. We'll just remove the word COVID. And so now, because COVID itself is gone, the other words can become a little bit bigger, which is nice. And now finally, maybe let's only keep the everything starting with a hashtag. And there we go. This is the hashtag cloud, the tag cloud of all the hashtags used in English language tweets about Corona. We still see, of course, that a lot of it contains the word COVID. So we could also add an asterisk here to get rid of these. And then it's getting a little bit better. And so we see it's about coronavirus, which is what it's called in a lot of countries. It's about Trump, the pandemic, SARS-CoV, another word, etc. Now I focus on the hashtags here. You could also remove the hashtags. You could only look at the add mentions. You could look at other words. You can look at other languages. There's a lot of things you can play around here with. And again, all of it is contained in fairly simple commands to create a document feature matrix, remove some words, keep some other words, and make a word cloud. So I would say take this code, have some fun with it, see what else you can do. We, in the meantime, will go to a second cool thing you can do with text, that's namely run a topic model. A topic model is basically asking the computer to automatically cluster all the words and all the tweets into a limited number of topics. And for example, you could hope that maybe all the American politics will go into one topic, and maybe all the economic consequences or all the health consequences will go in another topic. Of course, whether they actually go into a topic depends on how coherent people are in what things they talk about, because something will go into a topic if two words go into a topic if they are often used in the same tweets. Now we activate the topic models package, and then we need to convert the DTM to a topic model DTM. One of the problems with so in R everything is developed by different people. It's developed in different libraries. So they don't necessarily use the same formats, they don't use the same objects. So the Quantida package uses a different document feature matrix than the topic models package, which seems to be a problem, but fortunately the nice Quantida people gave us a simple function to convert from their format to the formats used by other packages. So we now convert it to a topic model DTM, which we'll call M. And now we can immediately just run an LDA on this, asking, for example, for 10 topics. And maybe M was a stupid name here, so let's call this D for the topic model. And we'll call the actual LDA model M. So now it's running the LDA model, and we can inspect the LDA model by asking for the top 10 terms in each of the topics. And let's actually view this to get it into our screen here. So what you see here is basically the top 10 topics of the top 10 words, of all of the 10 topics. Right, so here we have one that is apparently about what we do about it, social distancing, healthcare, stay safe, working from home, remote working. So you can see a number of things are taken together. Here's the India, Muslims, Islamophobia, Gandhi, Nehru cluster. Now, of course, these topics don't necessarily make total sense, although you can definitely interpret some of these more easily than others. And my advice is always to not just look at the top words here, but also to go into more detail into seeing what these topics are actually about, by also inspecting the tweets belonging to the certain topics, and also selecting tweets that are just in between various topics. And that gives you a much better idea of what a topic is about than just this list. Also, of course, I chose 10 topics. Maybe 10 is too many topics. Maybe 10 is not enough topics. And the problem for the computer is that every hashtag needs to be assigned to a topic. So if there's really only 3 topics in the corpus, then it will still assign those 3, all the tags to the 10 topics, because that's what I asked for. Again, what is cool about this is that you can see that you only need 2 simple lines to run a topic model from the DTM that we created earlier. You can play around with this a lot. You can change the number of topics here. Of course, you can also change the things you did over here to not get only the hashtags, but maybe all the words, maybe even all the words except for the hashtags, maybe the app mentions to see which people are clustered into groups. You could take other language tweets. For example, you can take Spanish or French. Let's have a look at what is there. So we can use the table command for this. And so you can see that, of course, English has most tweets, but there's also a sizable amount of French tweets. And there's quite a lot of Spanish tweets, some Italian tweets. And I have to admit, I have no idea what UND is as a language, but we can figure out, I suppose. But now we could run exactly the same, but for example, we could say I'm only interested in the Spanish tweets. And then we get a word cloud of tags used in Spain. Let's make this a little bit bigger to make it visible. I can see that they talk about Mexico, Salud, Sinadef, which I have no idea. es urgente agente. So these are obviously tweets used in Spanish language tweets, and we can also run a topic model of those Spanish language tweets. And then you see that there, and again, those are all the Spanish hashtags used. I have no idea what they mean, but hopefully somebody that speaks Spanish can make sense of it here. Now, again, take this code, see what you can change, play around with it, and just have fun. So what else can we do with the Twitter data? If we have a look again at what's actually contained in the Twitter data, you might remember that we also have the location of some people. Now, some of them, some users didn't give their location, right? So apparently Bior didn't want to tell him where he lives, or she, of course. Others fill in something nonsense like un peu partout, a little bit of everywhere. And you'll probably find quite other things. Some people give their email address here in the location, which is kind of silly. Other people, I'm sure, like the White House, I'm not sure if Women for Biden lives there. Maybe they want to live there. But you can see also that quite a number of users actually are very serious about this. So they just say Lahore, Pakistan, Florida, Taipei, New York. These are actual place names. And we would love to do some analysis there. Only the first problem here is that these are textual, right? Is the word Lahore, and we'd like to convert this to an actual coordinates. That seems like a big problem. The cool thing is there's a library that does exactly that, the map tools, which contains something called Geocode. Using the OpenStreetMap here, we could also use Google, but then you'd have to log in, get a token, it's all complicated. What we can look up, for example, where Amsterdam is, and it will tell us that Amsterdam is 5 degrees east and 52 degrees north, which sounds correct to me. If you request a single one, you get it displayed like this, but if you request multiple locations like Amsterdam and New York, it will give you a nice little data frame like the way we're used to it. So what we could do now is actually take all the locations mentioned here in the tweets and look up their locations and then rejoin that with this data set. Now that will take quite a lot of time to use this service to ask for 5,000 locations. So instead we're going to be cheating a little bit again, and take a CSV that I prepared for this, again from the website of the book, which we call the COVID users.csv. And the users contain for each of the screen names, their location, and the latitude and longitude according to the geocoding algorithm. And you can see that for some of them it got it immediately, and for something like un peu partout it couldn't find any location, so there's a missing value. But you'll see that for quite a lot of them it actually did find the latitude and longitude. Now we need to merge this data with the original tweets, which sounds a little bit complicated maybe, but it's really simple. We can just immediately merge them like this, and then it says I'm joining them by screen name and location. So if they look up the screen name and location, if it matches here, it'll get the additional data, which you can see here. That's now this first tweet has a latitude and longitude connected with it as well. Right, so that's cool, I suppose. But what can we do with this? So one thing we could do, of course, is just ggplot this. So we could ggplot the these tweets and put the x as the longitude and the y as the latitude. And then of course we actually need to put the tweets down there, so we'll call that the point. So these are the locations from which our users have tweeted. And you can sort of make out the outlines of the continents, which is kind of cool. You can see that not a lot of people are tweeting from Russia, and probably the ones that gave in Russia as a coordinates got put in the middle of Russia. A lot of from Europe, a lot from the United States, a lot from the Caribbeans, and from the sort of Buenos Aires, Rio de Janeiro, and other big cities in South America. Africa is a lot sparser, and also East Asia is a lot sparser than Australia. Of course, it would be really cool if we could actually add the map data there. For that, you need the package called map data, which I think is called map data. Now I'm actually need to cheat a little bit. Yeah, it's called map data. So you will need to install that one if you want to go along with me. I've already installed it, so I won't run it again because that takes quite a bit of time. Because now what would be cool if we could actually plot the Earth as well, right? The countries that we know, which are all contained in the map data in something called the map data worlds. So if we look at the map data worlds, you can see that what it actually says is that there's something called Aruba, which is one of the Dutch Caribbean islands, which you can draw by going to this location and then draw a line to this, draw a line there, etc. Right? So this is the first set of instructions to draw the island of Aruba. Some countries, like the United States, presumably are more complicated, and Canada as well. So this is the mainland, but there will also be islands which then get a different group. Oh, the is the big house. This is a different group. So each region of the country gets a different group with lines to draw it. So we are going to do a polygon here. The data here is the map data world. And let's actually see what happens if we do it like this. Now, the reason it's looking so messy is that we never told it how to use this grouping variable. So the problem is that now it draws the first island, then it goes to the next region, then it goes to the next region, and it just kind of makes a big mess of this. So we are going to add a mapping here that says basically the group should be the group. And now, of course, I couldn't have done this here. The problem is that the points data, the tweets themselves don't have this group. So this mapping is only valid for the polygons. So let's add it at the polygon level. Right, and now voila, we see our beloved continents drawn in gray with the tweets in black on top of them. The problem is, however, that actually the tweets aren't in top at this moment. The countries are on top. So let's switch that around and first draw the polygons of the continents and then the points of the country of the tweets. So this is already a little bit better. Now it would be nicer if these were red. This is starting to look like it, but actually let's also give them a little bit of transparency there so that you can see probably more than that, so that you can actually see where there are more tweets or fewer tweets. And so now you can see a little bit that this is like deep red, these are smaller. You can also do something like have the size connected to the number of retweets, which I think is called the retweet count. And then you see that the tweets that are bigger are retweeted more often. Now probably we don't want to, we also want to make them a little bit less transparent, so we'll also put the alpha here on the retweet count. And so now we're getting something quite nice. You can see this probably the first tweet we looked at, the one about secularism in India. These are some other popular tweets, and the less retweeted tweets are smaller there. And here you can see the legends, how it goes from 0 to 1200 retweets. Now this is sort of ugly, right? We don't really want the latitude and longitude there, so let's add a empty theme, a void theme. This is better. And then of course we can also drop this guide here, this legend here. So we'll just say guides. We don't need a legend for the alpha, and we don't need a legend for the size. And now we only have our picture here. So we've now used the locations to visualize them. We can also use those locations in an analysis. For example, we see that the biggest two regions from tweeting are basically North America and Europe. Let's see if the tweets from North America differ from the tweets in the rest of the world. Do American tweets differ from non-American tweets? To do this, of course, we need to classify every tweet as being either North American or not. So let's say we use mutate to compute a new variable. We'll just call it North America. And we will use an if else here to basically say if it's one value, it should be this, and if it's another, it should be something else. Now, if the longitude is smaller than -60, which is about, should be about here, and the latitude is above 25 north, so that's approximately this point. Everything to the northwest of this point we'll call North America. Now that's a little bit crude. Some parts of Mexico will be included, some parts won't be included, but for now that should be fine. Now if it is in that region, we'll just call it American, and otherwise we'll call it the rest. And what we see here is that if we run this, it has classified every tweet that we have a location for as either American or rest of the world. Now, because we just run the command like this, it displays it on the screen. It doesn't actually store the changes. For that we need to assign it to a variable, to a name. So here we just assign it back to the tweet's name, so it overrides the existing data set. So now our data set actually has a new column, so now the tweets have 11 columns instead of the 10 that it had before. So what can we do with it? Let's make a new document feature matrix from the tweets. So let's again filter the tweets to only get the English language tweets. Otherwise we'll see that Americans talk English and the rest of the world doesn't always talk English. Then we will create something called a corpus. So if we do that, then you'll see that it creates a corpus consisting of those 6,000 documents and 10 docvars, presumably because it dropped the ones that only took the English ones. We can actually also say we want to filter on, we just filter on that it shouldn't be missing the location, or actually it shouldn't be missing the North America variable. Oh, I mistyped here. Sorry, it should be an H. And so now we have about 4,000 tweets left in our corpus. And the corpus can be now converted into a document feature matrix again, where we do some of the standard steps. So we lowercase, we remove English stop words because those aren't that interesting. We remove punctuation. And so this is all fairly standard, but there's one additional thing we can do. We say we want to group this document feature matrix by our North America value. And this will actually give us a document feature matrix with only 2 documents. So one document representing America, which talks about secularism and Gandhi only once, and one document about the rest, which talks about secularism and Gandhi quite a lot. Probably those are retweets. It talks about India, etc., etc. Now what we want to know is which words are typical for American tweets and which words are typical for non-American tweets. So let's actually store this. And so now we store the results in a variable called dfm, so we can use it later. And we will use something which is called text set keyness to get how key a word is to a certain group. And we run it on the dfm. And we say our target is, and what did we call it? We called it American. Our target is American. So what it did now is for every word, like governor, it computed how often it's in the target group, how often it's in the reference group, and it gives a chi-square measure of how surprising it is that North Americans use the word governor so often. And this is sorted by chi-squared, so you can see here that Americans really love talking about governor, about Trump, about Pelosi. And if I reverse the ordering, and you'll see that they really don't like to talk about Corona Info Switzerland, about SARS-CoV, because it's not called SARS-CoV there. They don't actually like the label Corona. They don't like talking about India. They don't like talking about COVID UK, etc. Right? So what you see here is these are the words that are favored in the rest of the world, and these are the words that are favored in America. Now we can also plot this by doing a text plot keyness, and then you get, oops, I forgot the closing brackets. And let's make this a little bit bigger so I can actually read it. So here you can see a representation of exactly the same information. So you can see that Americans talk about governor, Trump, Pelosi, Americans, Florida, Trump, and probably a governor here, Fox News, Center for Disease Control, etc. While non-Americans talk about the lockdown more, about Boris Johnson, National Health Service, also talk about Beirut, about Epstein, about India, etc. And so what we've seen now is basically two things. One is how you can, or three things maybe. One is how easy it is to figure out where a certain location is using an online service from OpenStreetMaps. The second is that you can use that information fairly easily to make a plot of the world with the location of all the tweets that we resolved. And finally, you've seen how you can also use that information to, for example, differentiate between American and non-American tweets. Now again, just copy this code, play around with it a little bit. Maybe you can compare European to Indian tweets. Maybe you can compare Spanish language tweets in the United States with Spanish language tweets outside of the United States. You can also differentiate only the hashtags, or you can only differentiate which people they talk about. And so you can use this information for quite a number of things. I'd say have fun with it, and then we go on to the last topic of today. So for the last topic of today, we're going to look at network analysis, because of course Twitter is a microblogging service where people can say things and hopefully other people listen. But Twitter is also a social network, and we can also treat the tweets as a indications of a social network, who is following whom, or in this case, who is retweeting whom. So if we look at the data sets, we're going to, sorry, that's not the data I was going to look at. If we look at the tweets, you can see that this user here, in fact, didn't reply to anybody. But if we sort by who they replied to, you can see here that 2 people replied to 10 Downing Streets, or actually a Big Bass replied to 10 Downing Street twice. So if we interpret this as a social network, we'd like to have a node called Big Bass, and we have a node called 10 Downing Streets, and there should be a link from this node to the other node, because Big Bass actually replied twice to 10 Downing Streets. So that's the network we want to construct. And to do this, we'll take our tweets, and to make it easier, we're just going to select a from and a to. The from in this case is the screen name, the user, and the to is going to be the user that he replied to. Now, in most of the tweets, actually, there was a user, but there wasn't anybody they replied to. So let's get rid of those. We'll omit the missing values. And now we see here that this guy replied to himself, and some person called DalbitEU replied to ABC Poppins. Now, we would like actually to merge all the links where the same person replied to the same person, like we saw with Big Bass replying to 10 Downing Street. So we're going to group by from and to, and we're going to summarize to get the count for each pair of users. So here Carlotta replied to Naimu once, Baita replied to this person once, and if we store this as our edges data sets, we can also have a look at where some more action is happening. So apparently the most replies in the dataset are from American 121, replying 19 times to Speaker Pelosi. I think that's getting close to badgering. And for example here, call me Ambrius Ain, replying to real Donald Trump 5 times. Now this is a social network, but to analyze it, it's best to convert it from a data frame into an actual social network object, which we use the package igraph for. And it has a graph from data frame command, which will just give it our edges, and then it turns it into a graph. And you can see here it's a graph with 2,500 nodes, 1,600 vertices, connections between those nodes, and you can see basically the first list of links. So the first one is again Carlotta replying to Naimu, etc., etc. So all of the connections that it has here are included. We could plot this. That's a really bad idea, but we could do it anyway. And then you'll see that it's going to try to put all those 1,600 nodes in one plot. So these are basically all our users, and all these lines are connections between the users. This is not pretty, and we'd like it to be pretty, so we're going to have to do some work here. The first thing we could do is to decompose the graph in its connected components, because probably a lot of people are not connected in a tweet network. A lot of people will just have one link or two links between them. And then we can ask for the size of each component. So we can see here that these components are actually 1100 components, and it's a list, and each of the entries in the list is going to be a single connected network. So let us find out how big they are by running the command called gsize graph size on each of the components. And there you see, for example, the first graph only has one link. The second component has 5. So let's actually get that one. Let's call that G2. So we ask for the second component. And G2 is now a graph with 5 edges between 6 users. And we could plot this, and it's going to be hopefully slightly more rewarding. And so we can see actually there's a account called PressSec, which is probably a press secretary, and there's a number of people replying to somebody this press secretary tweeted about. Now let's actually find out what the biggest component is. So let's sort this in decreasing order. Oh, that was not very useful. What we actually want to do, of course, is to, because now we just know that it's 108, so now we could ask which of our sizes, so let's actually call these sizes. And so these are my sizes, and if I sort them, and so the biggest size was 108, so now we could ask which of my sizes equals 108. And it's the 42nd component is the biggest component here. We could also have done this in one command with the which max commands, and then it will give the answer right away. So it doesn't matter how we do it. We want component 42, which for the nerds among us is obviously the answer anyway. So let's get this graph number 42. And now we see here that there's actually about 108 users and 106 connections. So we could plot this, and now it's already starting to look a little bit better, but it still has too much data here. So what we can do now to make it better is to, for example, drop all the labels, or we include only some of the labels. And I'm going to cheat a little bit and actually get the code I prepared for this, because there's just too much code here to do, and I'll run each command at the same time. So first we're going to cluster it, and clustering means it's going to find out which of those form cohesive subclusters, and we're going to give them a nice little color for each of the subclusters, and then you'll see that so these the gray cluster, the pink cluster, the orange cluster in the middle, here's a cluster, here's a cluster. That is just a nice way to add some color to the picture. Now what's more important is we're going to take the degree, so how many connections somebody has, and use that to make the label smaller or bigger. And crucially, we're only going to display those names where somebody has more than one incoming connection. And we're going to make the arrows a little bit smaller because those arrows are just enormous. And now actually it starts to make sense. So what we see here, there's a network where real Donald Trump is right in the middle. So we have a lot of people replying to real Donald Trump, and a lot of them, the orange cluster, only replies to Donald Trump and nobody replies to them. But we also see that some people, like the Daniel here, replies to Donald Trump, and then a lot of people reply to the Daniel again, and the same happens here. And so here you can really see the network emerging of which people are replying to what other people. So as a final thing, let's actually see if we can plot this reply network on the map that we made earlier. So we have our edges. The edges contain the users, and we also have a users file, which we loaded earlier, which for every user lists the location of the user. So we want to combine this, and actually we want to combine it twice. So we have the name of the location of the sender, and we have the location of the receiver. So we're going to join the edges with the users, and we're going to say that the from should be linked to the screen name. And if you see that here, then you'll see that Carlotta is at 50 by 1. which is presumably in France. And this person, animal advocate, didn't give a relocation. The location gave an earthling, aren't we all? Which it couldn't actually resolve to a geographic location. Now let's also do the same for the two users. So we're going to be joining this again. I'll just copy the code here, that's easiest. Only then we don't join it to the to, but we join it to the from. Now if we do this, of course, it will have duplicate names, location, latitude, longitude will occur twice. It'll automatically assign a little suffix variable here. Now I don't really like those plus x plus x's, so what I'm going to do is tell it to not give a suffix on the first one, and give a to suffix on the second one, so remember which one is the from, which one is the to. And so now it's becoming a little bit better. So we have the from with their location, latitude and longitude, and we have their to with their location, latitude and longitude, and of course how often they have it. So that's good, but we need to store this, of course. So I'll call this edges2, and then we want to do two things, namely we want to drop all the missing values again, and we want to filter where we don't want edges from one person to the same person, so we're just going to say the latitude should be not the same as the to latitude, and the longitude should be not the same as the long latitude. So now we have a list of edges, which basically says that somebody from France replied to not somebody to Marseille, and so it's going to be a short edge, and here somebody from Los Angeles replied to somebody from Boston, which will be a slightly longer edge. Now we have our data, so let's actually go up all the way and get this data that we already had. So we already had this plot with all the tweets, and now let's just add a curve geometry, and the from, the longitude and latitude are the froms, but we also need to tell it where it goes to. So the end is going to be the long 2, and the y end is going to be the latitude 2. And let's use the n for how big it is. And the data should be these edges. So let's just make this a little bit bigger so you can see what I'm doing. And then finally, we probably want to give it some transparency, and let's not make it too curvy. So do a curvature of 0.1. And what do we have here? We actually now see all the replies. Let's make this one a little bit lighter so we can see it more easily. Let's fill it with light gray. And while we're at it, let's also do this. And so now we also see the different countries there. So what you see here is as expected, Americans tweet a lot with Americans, Europeans tweet a lot with Europeans, Indians tweet a lot with Indians, and from between my eyelashes, if I look at the pattern, I would say that most of the other regions are also replying to America, and there's not a lot of connections between the various regions themselves. Now again, this is a completely random data set. The locations cannot be trusted. Only a minority of people actually gave their locations, yada yada yada. So probably you can't quite write your PhD thesis on this, but what you can see, and that's hopefully the message from, of course, all the examples in this session, but what you can see is that you, if you use a number of normal data wrangling commands, which we'll be see in more detail in one of the following sessions, you can transform the data into the data sets that you actually answer the questions that you have. And then there are some relatively simple commands, like the ggplot here, that contain a number of building blocks like polygons, points, curves, themes, guides, labels, etc. that are the same every time. And if you learn all these simple building blocks and you learn how to use those different building blocks together, then you can actually do a lot of really cool and really powerful things with R. Now, again, take this data, take the code, start playing around with it, see what you can do. Don't be afraid to mess it up. It's totally fine. You can't damage anything. You can't do anything really bad. Just have fun, see what you can do, see how far you get, and play around with it. All right, have fun and see you later. Bye.